Okay, so the last week we have discussing about the properties of discrete Fourier transform. Okay, so we have discussed about the linearity property and periodicity property. So this week we continue with the properties of Fourier transforms. The other properties will be continuing here. And last week also I covered the circular sequence. How do I sequence a periodic sequence can be extended, or if extend is there, how the circularly sequence can be extended, that also I covered in the last week. Okay, so this week we continue with the properties of discrete Fourier transform, and the first property is symmetry property of discrete Fourier transform. So last week I have covered symmetry property of the sequence. Here I will cover symmetry properties of the discrete Fourier transform. So what is symmetry property of discrete Fourier transform? Okay, so let's start from the math and then we go for the physical explanation. So what is the math? Let's say I have a signal x of n. X of n is a signal which is nothing but a real and imaginary. So it is a complex signal which has a real part xrn and has an imaginary part xin. Okay, if I take the DFT of x of n, if I take the DFT, n point DFT, I get xk. Now xk is also an complex, it also has a real part and has an imaginary part. Now let's derive what should be the expression of xk. So how do I derive this? Now I know xk is equal to n equal to 0 to n minus 1 x of n e to the power minus j 2 pi by n into nk. That is discrete Fourier transform. Now these can be written n equal to 0 to n minus 1 x of n. So e to the power minus j theta is nothing but I can say cos 2 pi by n into nk minus j sin 2 pi by n into nk. E to the power minus j theta, e to the power minus j theta is equal to cos theta minus j sin theta. Okay, I have written down. Now if it is that, now if I put the value of x of n equal to 0 to n minus 1, what is x of n? X of rn real part plus j x of in, which is imaginary part of the input signal, multiply by cos 2 pi by n nk minus j sin 2 pi by n nk. Okay. Now let's say I consider this is an A, this is an B, and this is an, let's say A1 and this is an B1. So I can say that x of k is nothing but n equal to 0 to n minus 1 a plus jb multiply by a1 minus j b1. So if I do the product n equal to 0 to n minus 1, so it will be a1 minus j ab1 plus j ba1 minus j minus 1, so it will be plus a b1. Sorry, b1. So now I put the value of a and b. n equal to 0 to n minus 1. What is a? A is nothing but a xrn. What is a1? A1 is nothing but a cos 2 pi by n nk. So it is cos 2 pi by n nk. Real part, this one is also real part, so plus I write this one first. So what is b? B is nothing but a xin, imaginary part of input signal. What is b? B1, it is nothing but a sine 2 pi by n nk. So this is one part. Next part, if I take the minus sign common, minus j, then I can say it is, if I take the minus j common, so it is minus j if I take common a b1 minus b a1. Okay, so minus j a b1, a is nothing but a xrn into b a b1, b1 is nothing but a sine 2 pi by n into nk minus BA1, BA1, B is nothing but a xin into A1 is nothing but a cos 2 pi by n into nk. So I can say this is an x of r and this is an x of I. So this is an one transformation, this is the real part of the transformation and this is the imaginary part of the transformation. So I can say that xk is nothing but a xr minus j xi. So if I want to make it plus, if I want to make it plus j xi, then if I want to make it plus means if I, so this will be this side, so I can say ba1 minus ab1. So this is ba1 will be this side and ab1 will be this side. So I can say the expression of xr is nothing but a xrn cos 2 pi by kn by n and xi into sine, and xi is nothing but a minus of this one. So if I say the plus, if I say it is plus, so I can say minus of this one is nothing but a xi. So minus of this one is nothing but a xr sine and x minus xi cos, minus xi cos. So xi will be cos and xr will be sine. So I can calculate that xr expression and xi expression. So I know that xr expression and xi expression. Similarly, if I take the inverse transform of xk, so xk is equal to xr plus j of xi, and xr is this one and xi is this one. Now if I say I want to calculate x of n, so x of n is equal to 1 by n, k equal to 0 to n minus 1, x of k multiply by e to the power plus j 2 pi by n into nk. Okay or not? Now if you put the value of xr and xij, again if I put same way, if I calculate 1 by n, k equal to 0 to n minus 1, x of r plus j of x of I multiply by cos 2 pi by n into nk plus j sin 2 pi by n into nk. If I do that, I get xr expression and xi expression. So I get x of n is equal to x of rn plus j x of in. So expression of that x of rn will be this one and expression of the x of in will be this one. You can do it. Again you take, this is a, b, this is a1 and b1, then take the product and calculate the real part and imaginary part. So you can get the expression of xr of n, real part is xr of n and imaginary part is xi of n. So I derive, if I have a complex input, this is my frequency domain DFT representation of xrk and xik, and if I take the inverse DFT, I get the xrk and xik, or you can say that this is not k, this is n. If it is k, then it will be n equal to, if it is n, then it will be k equal to. Okay. So xi, I can say n instead of k, I can write n. Okay, and why this one is k? This one is not n. K equal to 0 to n minus 1. K equal to 0 to n minus 1. This one will be n. Okay, so x of n, xr n and xi n. Xr n, this is the expression, and xi n, this is the expression. So this is the 4 equation I get. Now consider the sequence. So what is the sequence? Let's say I have a real valued sequence. Okay, should I derive it? Let's say derived it, because you may have a confusion how we get that xr and xi. So let's say what I said, x of n is equal to k equal to 0 to n minus 1 x of rk plus j x of ik multiply by cos 2 pi by n into nk plus j sin 2 pi by n into nk. So I consider this is nothing but a, this is nothing but a b, this is nothing but a a1, this is nothing but a b1, so it is nothing but a k equal to 0 to n minus 1 a plus jb multiply by a1 plus jb1, which is nothing but a k equal to 0 to n minus 1 a1 plus jab1 plus jba1 minus bb1. So I can say it has a two part. One part is k equal to 0 to n minus 1 a1 minus bb1, which is nothing but a x of small x of rn, and another summation part is k equal to 0 to n minus 1 j, if I take common, so it is nothing but a b1 plus ba1, which is the xi part. So what is xr? Small x rn, a1, a is nothing but a x of rk multiply by a1 cos 2 pi by n nk minus b, b is x capital X I k into b1, b1 is sin 2 pi by n nk, and x of in, small x in, is nothing but a b1, a is x of rk into b1, b1 is nothing but a sin 2 pi by n into nk plus ba1 j into b means x b means what? B means xik, capital Xik into a1 cos 2 pi by n into nk. See that expression in here? Same. This is minus and this is plus. This is n and this will be k. This is n. Okay. So now I consider the real, let's say the x of n is a real valued sequence. That means I shall x of n is equal to x of rn plus j x of in. So I said x of in equal to 0. That means real valued sequence. So if x of in equal to 0, then what should be my x of rk? X of rk, this part is 0. So I can say x of rk is nothing but a n equal to 0 to n minus 1 x of r cos 2 pi by n into nk. And what is x of ik? Is nothing but a n equal to 0 to n minus 1. So this part is 0. So x of r minus x of rn into sine 2 pi by n nk. So I can say x of k is nothing but a x of rk plus j x of ik. So I can write down x of k. Okay. So x of k becomes this plus j of this minus j of this. Okay. So if the sequence is real, it also can be shown that x of n minus k is nothing but a complex conjugate of k, which is nothing but a x of minus k. If the sequence is real, x of n minus k, example, let's say I have a sequence x of n. Let's see whether it is happening. Let's say 1, 2, 3, 4. Now I know what said that if the sequence is real values, then x of n minus k will be the complex conjugate of xk, which is nothing but a x of minus k. Let's say I compute 4-point DFT. Okay, so 4-point DFT. That means x of 4 minus k equal to 0 is equal to star 0. X of 4 minus 1 equal to complex conjugate of 1. X of 4 minus 2 is equal to x of star 2. X of 4 minus 3 is equal to x of star 3. So that means x of 4, x of 3, x of 2, x of 1. So I can say if I take the DFT, I get the sequence x of k. So x of k means x of 0, x of 1, x of 2 or x of 3. I will get after taking the DFT. So if I take the DFT, I get those sequence. So what is the relationship between 1 and 3? So 3, x of 3 is the complex conjugate of 1. X of 3, these and these are complex conjugates. If the sequence is real. Similarly, 0, if I said x of 4 is there, 0 and 4 is complex conjugate. And 2 is itself complex conjugate. You can compute the DFT and see whether this property holds or not. This is a real sequence. This is the 0th sample. So if I know, let's say I said I have computed 8-point DFT, and if I know let's x1, x2, capital X2, capital X3, capital X4, I know I can calculate capital X5, capital X6 and capital X7. Now, what practical sense it is hold? So, if it is in complex conjugate, if I take only the magnitude part, both are same. So, I can say the magnitude part of x of, let's say x of 1 is equal to the magnitude part of x of 3. Okay. Now, suppose if I want to plot, I will take one extra slide here. What I know? I know magnitude of x of n minus k is equal to the magnitude of x complex conjugate k. Both are equal because a plus jb, the complex conjugate is a minus jb. So, the magnitude is root over of a square plus b square. Magnitude is root over of a square plus b square. So, both are same. And what are the relations between the theta? Theta is tan inverse B by A. Now here theta is tan inverse minus, so it is minus tan inverse B by A. Theta is same. One is positive, another one is negative. Now suppose I told you I have a real sequence x of n of length, let's say 1024, and I compute 1024 point DFT. I get x of k. Now if I plot the magnitude part of the x of k, what should I get? This axis is k and this axis is magnitude part of the x of k. If it is 4 point, you know the mod, if it is 4 point, the magnitude of 4 is equal to the magnitude of 0. Magnitude of the index 3 is equal to the magnitude of index 1. Magnitude of 2 is equal to magnitude of 2. Magnitude of 1 is equal to magnitude of 3. So I can say if it is 4 point, so if it is 4 point is n equal to 4. So I can say n by 2, I get an symmetry. So if I plot the magnitude part, let's say 1024 is equal to n, then n by 2 is 512. If I plot the magnitude of like this, let's say this magnitude are like this. Those are the k value changing. So this part will be repeated here because magnitude of x of n minus k is equal to complex conjugate of xk. If it is complex conjugate, magnitude are same, so I get a symmetry over here. So when I compute DFT of 1024 point, if I only interested about the magnitude spectra, then n by 2 point is sufficient for me. This part I do not require also to consider. So I compute 1024 point DFT, I get a DFT symmetry at n by 2 for a real valued sequence. If the sequence is real valued, then magnitude response has a symmetry property. So that is called DFT symmetry. Is it clear to all of you? So when I calculating, suppose I told you in a real problem, record a voice, let's say record a sound with 16 kilohertz. Okay. Now compute, let's say 1024 point DFT for a signal length of 1024 point, let's say. Then I get xk value which is varies from 0 to 1024. But I can say that all values are not distinct. All magnitude values are not distinct. So mod of xk will have a value of 0 to 1.24. So if I only take mod of xk of length 512 point, k is varies from 0 to and 512, I will get the magnitude response of the signal because this portion will be equal to this portion. That is called DFT symmetry. Is it clear? So this is DFT symmetry. Now suppose I want to calculate that, so this is my xk. Now if I take the IDFT, I should get back the x of n. So if we see x of r, not x of rk. So since x of in equal to 0, so this is not k, this is n. This is n. So x of in is nothing but a x of rn because My signal is real valued signal. So x of Rn, if I take the IDFT of this one, I will get this one. Because how do I get this one? Now I know that IDFT of x of n, so x of k is equal to x of Rk plus j of x of Ik. Now you know x of Rk is only this expression and x of Ik is only this expression. So these two expressions is only consist of xk. So if I see that here, come to here, x of Rk, x of Rn, so this part only exists, this part will not exist. So I get x of In, x of Rn is equal to this one. Okay, is it clear? So which is nothing but a x of R j Rk plus j x of Ik into e to the power minus e to the power plus 2 pi by n into nk. I can convert sin cos to e to the power, so which is nothing but a inverse transform, and I get the value of the real sequence. Okay, so this is real valued sequence symmetry. This is an important issue. So when you calculate DFT, if the sequence is real valued, then magnitude spectra doesn't require to be calculated for other part after k equal to n by 2. And also if I calculate x of k up to n by 2, I can assume what should be the, after n by 2, what should be the value. What is the meaning? Let's try take another slide here. I give an example and I explain it clearly to you. That suppose I told you that I have a signal, okay, let's say I have an xk, I have taken an 8-point DFT of a signal x of n, the n is equal to 8, the value of x0 is equal to let's 6, values of x1 is equal to let's 2 plus 3j, j3, x of 2 is equal to let's say 3, x of 4 is equal to let's say 5 plus 6j or j6. Then if I told you what should be the value of, let's say x of 5 is equal to let's say 2, then what should be the value of x of 6 and x of 7? Sorry, 5. So what should be the value of x of 5? So I can say 8-point DFT, x of n minus 3. So n is 8 minus 3 is equal to x star of 3. K equal to 3 I put. So it is nothing but a capital X5 is equal to x star of 3. So what is the 3? Sorry, 3 is this one. So 3 is 5 plus 4j. So what is the complex conjugate? 5 minus 6j. Similarly, if I x of 6, I want to say, then x of 6 is nothing but a capital X of 8 minus 2, which is nothing but a complex conjugate of 2. So which is nothing but a x of 2 is 3. So complex 3 is complex conjugate also 3. X of 7, which is nothing but a x of 8 minus 1, which is nothing but a complex conjugate of 1, which is nothing but a 2 minus 3j. So this is complex conjugate, this one. So I do not have to calculate all those values. If the sequence is real. Most of the cases when you calculate frequency transform, sequence is real. So this is called DFT symmetry property. Okay? Thank you.